Independent and dependent events. State standards are listed first, then you have your success criteria. Explain how independent events and dependent events are different. Determine whether events are independent, and find probabilities of independent and dependent events. Your vocab. Independent events. Two events are independent events when the occurrence of one event does not affect the occurrence of the other event. All right, so that's just like in real life. Something is independent if it doesn't, if something else doesn't affect the outcome. And then dependent event. Two events are dependent events when the occurrence of one event does affect the occurrence of the other event. All right, your key ideas that we need to talk about. First one, probability of independent events. Two events, A and B, are independent events if and only if the probability that both events occur is the product, that means you're multiplying, of the probabilities of the events. So P of A and B equals probability of A times the probability of B. So A and B, two events, A and B, are independent if and only if the product of the probability of A and B equals the product, the probability of A times the probability of B. All right, conditional probability and independent events. When two events, A and B, are independent, the conditional probability of A given B is equal to the probability of A, and the conditional probability of B given A is equal to the probability of B. All right, using symbols, probability of A given B, that's going to equal your probability of A. Okay, so it's the one that is the first one, probability of A. So probability of A given B is going to equal probability of just A. And the probability of B given A, again, is going to equal the first one, the probability of just B. So that's your conditional probability with independent events. Remember, there's got to be some condition that holds in order for this one to happen. And the last key idea, probability of dependent events. That means when something depends on something else. So if two events, A and B, are dependent events, then the probability that both events occur is the product of the probability of the first event and the conditional probability of the second event given the first event. All right, so written that out mathematically, the probability of A and B, and this is for dependent events, the probability of A and B equals the probability of A times the probability of B given A. So make sure these are in your notes, and as we go through a few examples, hopefully they will be easy to understand. Example 1, determining whether events are independent. A student taking a quiz randomly guesses the answers to 4 true-false questions. Use a sample space to determine whether guessing the correct answer to question 1 and guessing the correct answer to question 2 are independent events. Okay, so when it says use a sample space, basically that means make a table with all the outcomes. All right, this is the part that's a little tricky because you want to make a table with all the outcomes, but you don't want to miss any of the outcomes, because if you do, then it would make it more difficult to get the correct answer. So you've got to be careful. We know there are 4 true-false questions. So what are all the possibilities of getting 4 true-false questions correct or incorrect? So before we go to answer the question, we first need to just figure out our sample space. So I'm going to come over here to the right-hand side, and I'm just going to start thinking about outcomes. So we're talking about 4 true, false, questions. So we're going to have 4 questions. They can be all incorrect or all correct or whatever. So let's start with, okay, all 4 questions are incorrect. So that means you're going to get 4 questions that are wrong. So I'm going to use an X for incorrect and a check for correct answers. All right, then let's say we get 1 correct, but then we miss the other 3. All right, so let's miss the first one, but get the second one correct. And then let's miss the first 2 and get the third one correct. All right, and then let's say we get the last one correct. So let's say we missed the first 3 and we get the last one correct. So we started with all incorrect, and then you can see that I just moved the check mark over one space each time to try to make sure that I didn't miss any with only one correct answer. All right, now we can have maybe 2 correct answers. So let's start with 2 wrong and 2 correct. And then let's move one of the check marks over one. So we've got 1 incorrect, 1 correct, incorrect, incorrect. And then let's move the other check mark. Let's move this check mark over as well. So let's say we've got, I'm trying to do this systematically so that we don't miss any. So let's say incorrect, correct, correct, incorrect. All right, now we're going to do the same thing, except now we're going to move this check mark over to the beginning. So we're going to say this one goes to the front. So we're going to say correct, incorrect, incorrect on the end. All right, let's do correct, incorrect, correct, incorrect. So it's just a little bit different. It's the opposite of this one. You can see that the check marks are in the first and third space instead of the other 2. Now, we just don't have 2 check marks at the beginning, so we're going to move this check mark over beside of this one. So we're going to have correct, correct, incorrect, incorrect. And then let's have, okay, I think that's all the options for 2 correct. So now we're going to have incorrect and 3 correct. And then let's move the incorrect over one. So we're going to have correct, incorrect, and then we're going to have the incorrect one moved over once again. And then we're going to have the incorrect one be the last one. And then finally, like where we started, we had all the ones were incorrect. Now we're going to have all 4 are correct. Now I think there are 4 true-false answers, and I've got 4 by 4, which is 16. So this should be all the different possibilities of outcomes. And again, to me, this is the most difficult part, is making the sample space, because you got to be very careful not to miss any of the outcomes. Because if you miss the outcomes, then the probability certainly will not be correct. All right, now let's go back to look at the question. It says a student taking a quiz randomly guesses the answers to 4 true-false questions. Use a sample space to determine whether guessing the correct answer to question 1 and guessing the correct answer to question 2 are independent events. All right, so the probability that we're correct on question 1. All right, correct on question 1. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we're going to have 8 out of 16, or 1 over 2, 1/2. All right, now we need to do the percent, or the probability of correct on question 2. All right, question 2. There's 1, 2, 3, 4, 5, 6, 7, 8. So that one is also 8 over 16. which is 1/2. Now it says, guessing the correct answers to question 2. See if these are independent. So how do we know if they're independent? So the probability of A and B equals the probability of A times the probability of B. So what is A times B? Let's say this is probability of A right here, question 1. Probability of B, question 2. So that means we would have probability of question 1 correct and question 2. So that would be 1/2 times 1/2. Because remember up here it says probability of A times probability of B. All right, so 1/2 times 1/2 is 1/4. Because 1/2 and 1/2 equals 1/4, the events should equal 1/4 if we check these out. So what's the probability of question 1 and 2 being correct? So we've got to look at that. So question 1 and question 2 both correct. Here's 1 right here. So there's 1, 2, 3, 4. So this equals 4 over 16, which equals 1/4. Because this equals this, that means these are independent events. All right, so I got this by using the formula 1/2 times 1/2. I just used what we found here. Correct question 1, correct question 2. And then for this one, I went through and counted like I did before. So if you can see, let's see if I can get a highlighter here. Okay, so questions 1 and 2 are both correct. So here's 1 and 2, here's 1 and 2, here's 1 and 2, and here's 1 or 2. So that is 4 out of 16, and that equals 1/4. So because these are equal, that means these are independent events.